Okay, this question is asking us to do two things. The first one is to differentiate the function, and the second is find where the tangent to this curve is horizontal. So let's just start the beginning one. To differentiate it, the first thing that we need to do is remove square root sign, turn it into index form. Square root is the same as power half. Now I can find the derivative. I can use the chain rule for this one. It's the derivative of the outside times the derivative of the inside, which will be 2x minus 2. Now I need to neaten all this up. I'm going to go 2x minus 2, that's this piece, all over this 2. The negative half means on the bottom of a fraction and that it's a square root. Haven't finished yet. I see here I've got a common factor of 2. If I factorise this top line, what I would get is 2 lots of x minus 1. So what I can do then is cancel out this 2 and this 2, and that would leave me with x minus 1 on the top and the squared component underneath. This is our gradient function. This function can tell me the gradient anywhere that I like, or it can tell me where the function has certain value gradients. Useful, because that's what I need to do in the second part of this question. Where the tangent is horizontal. Horizontal means that the gradient is 0, flat. So I want to find where the gradient is equal to 0. So I set y equal to 0 and then solve. This can get a bit messy, so you can use your CAS. Y dash is this one divided by square root of x squared minus 2x plus 5, and I say that that equals 0. Now the only way this fraction can equal 0 is if the top component equals 0. We all know that if the bottom component equals 0, then it would be undefined. So we're really just interested in this piece here. So I'm going to say therefore x minus 1 must be equal to 0, so x equals 1. Didn't need to CAS for that. I do need to check that this value is not the same value that would make this function break by being defined underneath. So I'll just quickly put that in, and I'll do this mentally. If x equals 1, I'm going to have 1 minus 2 is minus 1 plus 5. I know that's not 0, so I'm safe. So the point here where the gradient is 0 is at the point where x equals 1. Now it's only half of a coordinate. I actually need a full coordinate. So to find the y, I need to use my original function. So I'll substitute my value x into my original function. So y will equal 1 squared minus 2 times 1 plus 5. This equals the square root of 1 plus 5 is 6, minus 2 is 4, equals 2. So the coordinate is 1, 2. That's my x piece and my y piece put together in a coordinate. This is where the tangent is horizontal.